Hey, hello, good morning. So for today's schedule lecture. We'll be going along with Unit 3. So this is effects and sound effects, as well as sort of procedural generation for your level. So in this unit, we'll be creating this sort of prototype for a sort of a side scroller game. So here is the example of what we want to achieve today. So there we have a player, and then our player just runs around, no, around the world, and then there are obstacles along the path. If I bump into an obstacle, player dies, and then the game resets. So if I bump into the ground, I use control of the player, as well as the player can only jump once and cannot jump while mid-air. So you have some restrictions. But if you want to say give like a power up to the player where it can double jump, then you may do so. Okay, something like this. Okay. Starting things off, we will use the assets from Unity, the ones that Unity provides. So in this case, we have prototype 3 starter files. So you can get this for the starting screen, etc. As well as the sprites for our background. So it's in your lesson 3.1 job force from Unity Create with Code. Okay, just download this file, unzip it, and then import it to your Unity project. So let's jump straight into Unity. So I have here a new Unity project. This one will import the assets. So click on assets, import package, custom package. I've already navigated to this directory before, so I'll just import this package for our unit 3 files or prototype files. Okay. Just import everything. And then just like before, now we'll put the scene, the prototype 3 scene into our hierarchy and delete our samples scene as soon as this finishes. Okay. So under our scenes folder, we have our prototype 3 and our sample scene. So we'll just drag prototype 3 into the hierarchy. And for the sample scene, we'll just remove the scene because we don't need it anymore. Okay, so we'll start with prototype 3 as our sample scene. This is what we see in our game window. And if we go to our scene view, looks like this. So it's just one big sort of board, you know? One big problem. One big sort of board, and we have our main camera here pointing there. So we have the main camera here, and we have our ground here. Okay. So first thing we should do is we don't have a player sprite yet. So we'll go to our course library and under characters, you could go to town or go to farm, depende on which one you want. And you can just select a sprite here. Sige, I'll say, let's take this sprite. No? I'll just drag it straight to the hierarchy, focus on it, and let's see. So it's still facing towards the background, which is not what we want. We actually want it to face to the right. So we'll just rotate it along the y-axis. I think 90 degrees on the y-axis is enough. There, it's now facing to the right. If we look at the game scene, it looks like this. Okay. Other thing I'll do is I'll move the main camera so that our player could be covered, like very visible around this part. You can also angle the camera a bit if you want. I'll angle it a bit like this. And then for the background, You could click on the background as well, and we could change the sprite for this background. So this case, we are doing the sort of suburban area, but if you click on the sprite, if you click on the small circles here, you will be given choices on which background we can choose. So for example, you can choose this, which is sort of like the city background, or you can choose this, which is the wilderness background. For this example, we'll use the sort of suburban area background. So my convenience store and church, etc. This player model or prefab, no, let's just rename this to player to keep things tidy. If we click on play right now, this will, well, proceed to your like just idle animation. So it just looks like that. It's just standing there. Okay. Next thing we should do is, according to the example I've shown you earlier, we want to make our player jump, right? Because it should jump over obstacles. So the first thing we should do here, we should create a rigid body as well as a collider for our player. So under add component, we could just add a collider first, collider, box collider, okay? And then under our scene view, let's fix the size of that collider. Okay. Okay. So our collider looks like that. I will edit it so that okay, so that it will encompass our player. Collider looks a bit like this. I'll just look at it from the top. I'll extend it a few units to the sides. Okay. So collider looks good. For this case, we want our collider to be an actual collider. This is so we could collide with the ground because our ground, if we look at it, also has a collider. And our player should also have a collider so it could stand on the ground. If this is set to trigger, then our player will just sink to the floor and we won't show it or we won't see it. The next thing we should do is to add a rigid body. Rigid body, this is for the physics. No? We have mass, we have velocity, etc. All of this are on your rigid body component. We should also use gravity here because, well, we will be using gravity and forces for this example. Okay, so right now, if I click on play, nothing really happens. Nothing much will happen. Okay, idle lang siya. It's still idle there. Nothing happens yet. We haven't coded anything yet, right? Sige. Okay. Let's go ahead and do some scripts. First, I'll create a folder to keep things organized for scripts. And then I will create a C# script for our player controller. So we could just name this player controller. Okay. And then we can add that to our player here. It's not yet, I think it hasn't compiled yet, but there. Okay, so I have attached it to the player. So our player has a transform animator, a collider, rigid body, and our player controller script. Let's go right into scripting. So what we want to do as a script is to add a rigid body reference. This is what we will use for adding forces to our player to make it jump, to make it run, etc. Okay. In this case, we'll just I'll put a serialized field here, serialized field. Private float. Say jump force. So this will be the variable that we will tweak in order for us to like play around with how much force is needed for our character to jump. But we will also have we should also have a reference to our rigid body component. So in this case, we want rigid body. Be careful, no? Rigid body, we're using rigid body because we are using it in a 3D environment. If we are using 2D environment, then we'll use rigid body 2D. This will be a reference to our rigid body component. So I'll just say player RB, like so. And then to get the reference, we should get it start. Okay, at the start, no, or at the spawning of our player sprite or player object, we should say player RB is equal to, and we'll call the function get component. So get component gets the specific component we want to use. In this case, rigid body. So we are telling Unity to get the rigid body component of this game object. Well, this will be attached to the player, so we'll get the rigid body component of the player. So this is the type of the component we want to get, and then we'll just attach the parentheses because it is a function. Okay, so we now have our rigid body controller. Okay. Next thing we want to do is check for user input. So for jump, let's go back to Unity for a bit and look at the inputs we could use. Okay, soon as it finishes, okay. So under edit, project settings, and then input manager, axis. So we have a jump here, jump the axis or jump button, and the positive button is space. If you are using a controller or if you want to code for a controller, the default for this is your Y button. Okay, so the axis is jump. Okay, so let's just take note of that. And we want our jump to be one button press is equal to one jump. No? So we don't check for prolonged press. So we will use input dot get button, not get button up, get button down. Okay, so this just checks if you have pressed the button. So in this case, we are looking for the jump input. Okay, and then we could say if this will return a Boolean value if the key is pressed, right? So we could say if our button is pressed, our jump button is pressed, we could say jump here, right? To add a jump on our player, we will call our rigid body component. So player RB dot add force. Now some of you have already used add force, no, on the MP2. It's not required, but well, some of you have familiarity with this now. So add force, the first thing we want is direction of the force. Now, usually we want our player to jump up. So we need force going up. So this is we'll use vector3 dot up. Okay, so for it to go up, and then we'll multiply it with the jump force. Now, this is the variable we'll tweak later on. Okay. Again, up is just shorthand for 0, 1, 0, right? So if we multiply this with the jump force, say jump force is 50, then that will be equal to 0, 50, 0, right? Okay. Just a refresher on like vectors and Boolean algebra, linear algebra, etc. Then we will add a force mode. Force mode here is impulse. Impulse in this case is a one-time add force thing. So imagine it like you are bumping something and then that force will throw an object away. So that's like impulse, right? Okay. So in this case, our script is sort of finished. We'll look at how it will behave on Unity. Okay, all right. Okay, let's click on play. Okay, so if we click on the space button, I'll press Y on my controller here. It flies away off the screen, right? So this is the part where we should tweak our, there, the player has landed. But if we just click on player, I'll do the rotation for, so it's easy to see. If I press on up or space there, it goes to space. It's not what we want, so we want to tweak the jump force, no, in order for this to be a bit believable. So jump force maybe, and this also goes along with the mass, no? I mean, bigger mass, you should have more force to for it to be pushed. Say our mass, I think maybe 50 kilograms of a person, right? That's reasonable. So if our mass is 50 and force is 50, you can see that it's jumping, but very, very minute. So you could add more jump force if you want. Say, I don't know, uh 200. Let's just check. So that still is a bit low. Maybe 250 is good. No. Let's say around 400. Is it good? Okay, that's pretty good, right? That's a pretty good jump. Jump uh jump height for a person, right? If we put like 500, yeah, I guess that's too high already. We decrease the mass, for example, 5 here. I'll also decrease here, say 40. Pwede man. So you could play around with these values. Sige, I might stick with this, mass equal to 5 and jump force equal to 40. Okay, but for you, you could do it however you. Okay. So for now, let's review again. Our jumping player just went out of play to input the values. Okay. So our player jumps, and while he's in midair, if you press space again, it's still jumping. That's not how humans jump. Not really, not really good game design here. But if you're like coding for something like Flappy Bird, if you've seen that game, maybe this is what you want. But for this case, we want the player only to jump when it is on the ground. For that, we will do some processes with colliders. Okay. First thing we have to do for that is for our ground to be tagged. So we could recognize that if we bump into the ground, if the collider happens with the ground, that well, we have collided with the ground, our player is on the ground, right? So we'll tag this first. So I'll click on tag here and then add tags. So we could have our custom tags. I'll click on plus and then say ground. Save. I'll go back to our ground and under tags, tag it as our ground. Okay, this is important for collision detection early, later. Okay. Okay. So for this, maybe we could have a boolean, private boolean or bool variable, say is on ground, and let's initialize it to true since our player starts on the ground anyway. And then for our jump, I'll add something here as well for the rigid body. This is angular velocity. I will just zero out our angular velocity. This is so that our player, when it jumps, it doesn't turn around. Because when it's turning around, then the impact to the ground is not as good. Maybe it will fall over or etc. Thing like that. So I'll just zero this out. And then I will create another if statement here. If is on ground. So if it is on the ground, if our player is on the ground, then we can jump. If it is not on the ground, then we won't jump, right? If we have jumped successfully, then we should be off the ground. So we will turn is on ground to false here. When should we turn back is on ground? When our player collides with the ground. So we will do that with on collision enter. On, so void on collision enter. Okay. There is also on collision enter 2D, which is for 2D colliders, but since we are using 3D environment, we will use 3D on collision enter. And this has parameters collision and then just the variable name other. Other is the other thing that collides with our player. Okay. So in this case, we'll provide an if statement here. So if other, which means the other thing that bumps into our player, dot game object dot compare tag. So this is the function, or yeah. So we will compare if the tag is equal to ground. So if our player has bumped to the ground, we say that is on ground equals, sorry, equals true in this case. Okay. Okay. Going back to Unity. Okay. Clicking on play. Okay. If I jump, it jumps. If I jump while I'm midair, it cannot do that. Right here. Here. Whereas you notice our player jumps, pero it falls down very slowly. To tweak this, we could tweak our physics. We could do this with the project settings, the physics, the component, or we could do this through code as well. We could do this through code. We could do it to start, no? Physics. We could call physics dot gravity, and then we'll just multiply it with a multiplier. We also want to use this multiplier, no? Say gravity multiplier. Okay. We want to expose this as a float para ma-tweak ta siya while on the go. So serialized field, private, float, gravity multiply. Let's start with I don't know, 10. And then we'll just edit it later. Okay. So it's in start. So whenever the player spawns, it will activate that gravity. Oops, sorry. Okay. So there, my very high gravity. So maybe you could lower that. No, it's since it's serialized here. Maybe 5 is good. 5 is still too much. Maybe 2. Okay. So since it's on start, we have to do it again. So maybe 2 is good enough. 10 is a bit too much. Okay. Okay. So the fall is still a bit too slow for me. So I'll add maybe times 3 gravity, but I will also triple the force that is needed for us to maybe 100 for us to jump. So we could just tweak the values now, however we want. Okay, a bit too high. Let's say 60. 60, no, or maybe around 80. Maybe around 70. So 70 jump force, and the falling speed is, I guess that's better, no? Yeah, that's better. Maybe let's put it 70. Yeah, that's much better. So 75 jump force, gravity multiplier is at 3. That's better. Okay, so now our player jumps, but it's not running around. It's just jumping on its wings. Okay, and it's also just standing. Okay, so there, it's just jumping. Nothing else happening yet. The next thing we want to do is we want to simulate that the town is moving or our player is moving. So there are two ways of doing this. It's either we can actually move the player to the right, or we could just simulate the player movement by moving the background. So usually what we do is we just move the background so that our player just stays in place, less calculation for force, etc. Right? Because if we are computing for force, then we have translate moving forward and then force going up. So it might mess around. Okay. So what we want to do is just move the background. We could also add obstacles. In fact, we'll do obstacles first, like moving obstacles first. So for that, let's select a obstacle for us to jump over. So you could have boulder, barrier, barrier 3, spool, stone wall. Since this is a suburban area, maybe we'll go with prop barrier here. Put it here, and then I'll move it around to see. Maybe here. Okay, maybe there, no? And then I'll just rename this to barrier obstacle. Okay. So currently it has a transform, but it doesn't have anything else. For it to collide with our player, we want a collider as well. So box collider should be good enough. Our collider looks like that. We could edit that. Edit this collider, like so. And then collides here. Okay. So we'll do this collision there, right? Okay. And we should also add a rigid body. Okay. I'll have the mass of this. Since our player weighs 5, I'll have this at mass 10 para ano siya, mass heavier. And when it collides with the player, it stays in place. Next thing we'll do, we could create a script for it. But before that, I will create a tag for it as well. So we could detect the collision with the obstacle later on. So I'll add a tag. So I'll name this obstacle. Save. Go back to our barrier obstacle. Under tag, we just tag it as there. Okay. Next thing we'll do, we want to make it move. Diba? We want our player to be stationary and the town and the obstacles will be moving towards it. Okay, so let's create a script that just says move left. So what this does, we'll just move something to the left. Okay. So for this, very easy. We just want a serialized field for our move speed. Serialized field, private float, move speed. I will initialize this at maybe 15F and we'll just tweak it later. And under update, we could just say move speed. I know, transform the translate. So this is going to the left, right? Left, vector 3 dot left times our move speed times time the delta time for frame rate independence. Okay. And then we'll just attach that move left to our barrier obstacle. There we go. Okay. Oh, okay, there we go. That's a bit too fast. Maybe I'll slow it down to around 8. So that was a bit too fast. Oh, oh, there we go. So yeah, go. The physics is a bit wacky, but it is slower now, right? There. So you can jump over obstacles now. Eight's a bit too slow. I'll just put it at 10 for a moderate speed. Okay. So right now we just have one obstacle, but we want to spawn multiple obstacles, right? So we'll create a spawner. Just like our animal spawners and some previous example. So in this case, we'll create a game object which is empty and we'll just label it as spawner. No, obstacle spawner. Okay. We'll reset the transform so it is at 0, 0, 0. If we observe our barrier obstacle, the y component is 0. So we should also have our y component for our obstacle as 0. Para when it spawns, it's not flying around. Right? Okay. So I'll put it somewhere just a little past the church, like maybe here. So it spawns there. Okay. Uh, let's create a script for a spawner. Okay, obstacle spawner. So for our obstacle spawner, the first thing we want is a reference to the object we want to spawn. So we'll serialize this field as private game object because it's a game object we want to spawn. Say obstacle. Okay. We'll assign a value for that in the inspector. And then I'll create a method here or a function, spawn obstacle. This case, we'll just instantiate. So instantiate the thing we want to instantiate, which is obstacle. Position where we want it to instantiate. In this case, I'll just instantiate it where the spawner is. Transform dot position, and then quaternion identity to preserve the original rotation of our object. Okay, so we'll do that as invoke repeating, like just like the animal spawner we did last. So invoke repeating, this will take a method name as a string, and then the first one is spawn time. The first call, the time before the first call. So maybe I'll put like 2F here, or maybe 3F. So 3 seconds after the game starts, it will start spawning. And then the other one we want to do, I'll serialize a field para so we can tweak it later. Spawn interval. Let's say 2F. Okay. Should be full. Okay. And then spawn interval. There. Okay, so we will call spawn obstacle after 3 seconds of the start, and then every after 2 seconds we will spawn an obstacle. Update, we won't be using that for now, but I'll leave that there just in case we want to do something in the future. Okay? Sige. We'll remove the first barrier obstacle. Before that, sige, wait lang. So before that, we want to create another folder for our prefabs. Prefabricate. Oh, that's a C# script. Sorry. I'll delete this for now. That's a C# script. We want a folder for prefabs. Okay, so let's create a prefab of our barrier obstacle. Just simply drag it to our assets folder as original prefab. Okay, and then we can remove this. Click on obstacle spawner, attach the script. So obstacle spawner script. And this will need a reference to our obstacle. We'll drag our barrier obstacle there and then save. And let's see how it goes. Okay. So after 3 seconds, it should spawn there. It has spawned our first obstacle, second obstacle, third. Okay. If we bump into the obstacle, physics gets wacky. Oh, sorry. Oh, wait. Okay. Again, if we play, okay, after 3 seconds, our obstacle should spawn. There it is. And there, just there. Ooh. Okay. Ooh. Okay. So my physics, my collision, that's good enough. Um, So our obstacles are now moving. We want to move our background as well. So our background should also move, right? So for our background, since we just want it to move to the side, then that's just as simple as just attaching the script move left, right? And I'll also move it at 10 para sabay siya sa obstacle. Okay? And then let's click on play. There, our background moves. There's an obstacle. Okay, jump over, jump over, jump over, and we run out of town. And you see the ugly truth that it's just a picture. Okay. So what's missing? We want to duplicate our background as well. Now in create with code, it will instruct you to calculate the midpoint of the sprite and then just put the sprite back to its original position. I don't want to do that right now because I want to like procedurally generate the background whenever we reach some X position, right? That is because we can then further add prefabs attached with the background in the future so that we can have prefabs of like blueprints of stages. Okay. So what I want to do here is create a spawner as well for the background. So to do that, let's go to our scene view for now. Let's zoom out a bit. Okay. I'll move this here. Okay. What I want to do is to sort of calculate where our spawner should go. In this case, let's duplicate our background just so we have a visual representation where we want our background to spawn or our other background to spawn. So I'll duplicate this with Control D. We have their background 1. I'll rename this to BG spawner. Okay, and then I'll just move it to the right, just around where it meets, like maybe around there. So there is a bit of gap, there's a bit of overlap. So we want our spawner to be located here, around here. We will also remove the move left script because we don't want our spawner to move. We just want to spawn our background. Okay, let's create a script for that. So under scripts, let's create a C# script, and we'll call it background BG spawner na lang. BG spawner. There. Let's open this. Okay, so if we want to spawn our background, what do we need? A reference to our background. So we'll serialize this field, private game object, let's say background. Background, yeah, sure. That's not how you spell background. And then we want to instantiate a background. So in this case, at the very start, since we are already here, the spawner is already here. At the very start, we immediately want to create or spawn a background para continuous siya. So in this case, we'll instantiate here. But we will also be instantiating later on. So let's just create a function for that, void spawn background. Background. Yeah, that's fine. So in this case, we'll just instantiate. Instantiate. We want to instantiate our background, right? As well as transform dot position on where our spawner is, and then finally quaternion identity to keep the rotation at default. We want to call this at the very start. Okay. Next thing we do is to prefab our background so we can have multiple spawnings of that background. So let's click on prefabs na folder. Let's drag it a bit here. And then click on our background and just drag it to the prefabs folder. Now we click on BG spawner and then just drag our background prefab. Oops. The script's not yet here. So let's have a background spawner script, BG spawner. Okay. And then we will click on background. So since we have our location for our background already, we can just turn off the sprite renderer here. We don't need that anymore. Okay. And let's look at it from scene view with just a little bit of game view at the top. At the very start, no, you can see that it has spawned another background. Ignore the player for now. But there, it has spawned a total of one background. We want this to be repeating, no? However, once we reach this point, we have run out of town again. So what we want to do is we have to spawn background every time that there is that our background has reached a specific position. For example, our background is here, right? In this position, we want to spawn another background. That's why we spawned at the start. But then we want to spawn again when that background has reached this position. Yes. So we spawn a background here just to show you. So we spawn the background here. It moves. It moves. It moves. It moves. Once it reaches this position, we want to spawn another background from here so that it continues the town. Right? Something like this. Okay. So what we want to do is to have sort of a reference to the background we just spawned. We could do that with this private game object last spawn background. Background like this, and then on instantiate, we could say that our last spawn background is equal to the thing we just instantiated. So instantiate creates an object, right? But it also returns a reference to the object that we just created. So we'll store it at our last spawn background. Okay, and then in our update, we will check if our last spawn background has reached that position or which position, however. Let's set this to null at first, and then we'll serialize a field here. Say float x spawn point. Okay, so in which x coordinate do we want to spawn a new background, right? Going back to our Unity, to our scene view, we want to spawn a background when our background position is at this point. Exactly, right? Because we want to spawn another background, it moves, it moves, it moves. Once it reaches this position, we will spawn another background, right? So we'll just look at the x position for this background, which is 45. So we say that if our background's x position is less than 45, less than or equal to 45, we'll spawn another background, okay? So we'll just copy that. I'll serialize it so if there are problems later on, we could still change that. So thing we'll do is we'll create an if statement here. If our our last spawn background is not equal to null, meaning we have spawned a background, and our last spawn backgrounds dot transform dot position dot x is less than or equal to our x spawn point. So if we have a background, if you have spawned a background, and if that last spawn background has this transform position less than 45 or equal to 45, we'll spawn another background. There. Okay. Gets ang logic. Okay. Sige. Let's test it. It moves. It has spawned a background clone here. Okay. Don't mind the player for now. So once it reaches this point, it should spawn another background. It did not. Oh, there, it spawned another background, so may something wrong with our calculation. Yeah. Yeah, there's a big gap here. Maybe our background spawner is too far. I'll just check again. Oh, let's check. 45 less than or equal to x spawn. Hmm. Uh, Obstacles on BG spawn. Ah, here. Naka-serialize siya at 0. So this should be 45. Okay. Again, let's check that again. So it spawned a background here. When it reaches position 45, it should spawn another background right about there. Okay, so it spawned another background. So continuous na siya, ang ating background, sort of. When it reaches 45, it should spawn another background here, there. So continuous na siya. There's a problem though, similar to our animals on the second example or unit 2, we have an infinite number of background spawning. So we have to destroy some of them. In this case, we could destroy it when it reaches a certain X position, or we could destroy it via time. Let's have a different take on this and just destroy it through X position. When it reaches an X position like this, we'll destroy it. We'll do the same thing with our obstacles as well. So for scripts, let's create another script. Destroy out of sight. So when it is out of sight, now we'll just destroy it. That's like the thought of it. Okay. Let's edit this script. So what we want to do here is just check if our transform position is less than that x, or x transform position is less than something, less than something. That something will serialize that field. So serialize field float. Let's see x out of sight. Sight like this, and we'll initialize it with, I don't know, -20 f. And we'll just test it around later on. Okay. Okay. So if it is less than or equal to x out of sight, we'll just destroy. So if this destroy game object. Nope. Game object. Okay. There. So if it is, if it has reached the position that it is out of sight, we'll just destroy it. Okay. We will attach this to both obstacle and the background. So we'll attach this to our background prefab. So we'll edit the prefab now, not the one in the scene. So we'll attach a component here. Destroy out of sight. Okay, what do we do for the X component? Let's see sa inspector and as well as sa game view. So our background is right here. X position niya is 45. So when does it go out of sight? At which X position does it go out of sight? Let's just drag it until it's out of sight completely. So around here, right? That's -63. So just take note of that value. We'll retract this to 45. And then let's put -63 here. There. For our obstacle, our barrier obstacle, sige, let's just spawn a sample obstacle here. And then let's also move it with the X coordinate as it goes out of sight around there. That's -5. Let's destroy it at, let's create a component So for barrier obstacle, add component, destroy out of sight. That is negative 5. There. Okay. Let's remove this barrier obstacle. Okay. Let's test. Okay. There's a barrier. I'll jump through it. Jump through it. Jump through it. Our barrier obstacles, if you see it since it's a hierarchy, is disappearing. Our background should also disappear. Oh, it disappeared too early. Ah, I know what happened. So sa background prefab, this is negative 20. Ah, so the background prefab, we set it as negative 20 because this is the default. We set the background here, ang iyang x out of sight is negative 63, right? But this is the right number. If we want to apply this to all existing prefabs or to existing prefabs in the future, we could click on overrides here and you can see the changes that have been, the changes for this specific game object and with the prefab. Right? If we want to revert all those changes and change it back to the prefab, we could press on revert all. That's not what we want to do. We want to apply the changes that we applied to this game object to the prefab. So we want to click on apply all. And if we look at the background prefab, it should be negative 63 here as well. Okay, check. Okay, there we go. There we go. There we go. There, it disappeared. First one disappeared correctly. Let's check the second one if it disappears at the right moment. And there. So okay na siya. Our background is a bit infinite and our obstacles are spawning indefinitely. Don't mind don't mind the character for now. Okay, I'll play it again just to be, just to check on what we're missing. Okay, so right now we have a town that's going to the left or simulating that our town or our player is moving or running to the right. So that's the obstacles here. But the problem is our character is just standing there. Even if it's jumping, it's just standing there menacingly. We have to change that. So we have to animate him. Or with a few things. So if we click on player, here's a hierarchy. We could see that there is an animator component. Okay, so this is given to us by Unity, and we can just edit it here. So may default na kitang animator. If we click on the controller here or the animator controller, double click on that, it will give us a lot of like animation states. Okay, that it might be intimidating to see for now, but it is actually very simple. Okay, let's start with movement here. So it looks like a web. I'll move entry here so it doesn't start there so far away. Okay. Let's try to understand this now. We have our entry, which is the starting point of all animations, and it defaults transition to when you see an arrow, this is a transition. So from entry, it will default transition to our idle animation. That's what you see that the player just like stands there menacingly. And then from idle, we can transition to either walk, walk static, run static, or run. In this case, our character is actually static. It's not running. It's staying on place, right? And we're moving the town to the left to simulate that it is running. So we are concerned here with walk static and run static. So walk static here, run static here. Okay. Let's look at the transition. So this is the transition. Let's look at the inspector. Okay. So this is the sort of the timing of the transition. You could sort of change that later. We'll look at it later. It also has a preview of what it does. So from idle, it will start walking like so, right? it also has some properties or conditions. These are the conditions of when to transition from idle to walk static. So the condition here is static B. That is a variable. That is a parameter. We'll look at parameters later on. So static B is equal to true, meaning it is static. And speed F is greater than 0.25. So when our speed is greater than 0.25, it will transition to walking. It can also transition to run static if our speed is greater than 0.5. Let's play that animation. So if our speed is greater than 0.5, it will start running. Okay? There. And static B is equal to true. Okay, so how do we know those parameters, or how do we see those parameters, those variables? We could click on, so this is layers, this is what you can see here. No? We can click on parameters, and there are a lot of parameters here. Don't be intimidated. We'll just use a bit, just some of it. Okay, speed F is this, right? If speed F is greater than 0.5, then our character will start running. Okay. The thing here is you are also guided on which type of parameter these are. So for example, speed F, there's an F at the end, meaning this is a float parameter, right? In this case, animation underscore int, this is an integer parameter. Trigger here is similar to your button down, right? When you press the trigger, then there, it is triggered. It's a one-time thing. Boolean is true or false, like this. So if you actually click on this jump trigger, it will trigger something like that. Let's play around with it so you can see the transitions. Okay, so our speed F right now. You know what? You know what? Let's disable the obstacle spawner for now, so we can see the animations. Okay, let's look at the animation. So speed F is at 0 right now. If I go to 0.3, for example, starts walking. Okay, if I go to 0.6, for example, it should start running, right? If I click on the jump trigger, oh, yeah, it tried to jump. It does try to jump like that. Yeah, so it also kind of changes your kinematics, right? We could also click on, say, death B. This is the boolean for death, right? So death B, if I click on death B, oh, it dies. There. There. If I click on jump while it's dead, it's not, because it's already dead. Okay? Okay. So what we want our character to automatically run. Since this is sort of a side-scrolling game, we want him to just start running, right? Okay. So at the very start of the game, he starts running. So we could just edit speed F at the beginning. And then when we want to jump, oh wow, he's still running on the air. So we need something in the code that will make him do the jump animation when we press the space button, right? Or the jump button. Sige. Sige. Let's go back to our scripts and our player controller. Again, which component was it of the player that does this? It is the animator. So then we will have a reference to our animator. So in this case, I'll just put it after rigid body. No, private. What's the component? Animator. Okay, animator, and they'll say player animator. We'll get a reference for it at the very start. Sorry. So player animator, and then I'll just copy this. Get component animator. There. Sige. So when we jump, here's the jump animation. Okay. We want this trigger. We want to activate this trigger. So we know it's a trigger, so we want to set a trigger, right? So we'll call on player animator dot set trigger. So you could set trigger, you could also set fall, set float, set boolean. You have a lot of things. Now depending on the properties or the transition that you want to make. So in this case, we want a trigger. We want to trigger the jump trigger now. So we could click on jump trigger and then double click on the name so we can copy it. So it's not, we don't make a mistake. Say set trigger, jump trigger. Okay, let's look at how it behaves for now. Okay, clicking on play, it loads. Okay, so it's running. If I click on jump, oh, it jumps, pero medyo weird, right? It also moves. Let's jump. We are concerned with this one, right? This is the jumping. And the transition for it is this jump. Okay. Required is just the jump trigger. Okay. It actually moves our player when it jumps. We don't want that. We want it to be static. Set trigger, jump trigger. Why does it? Let's look at the parameters. It should be static. Uh, Parameters. So we should be static B. So static B is, let's also check. Hmm. Jump B, I can't see. Jump B is set to false. Why does it move our player? Moves our player. That's not what we want. Okay. If it moves our player, it's not what we want. I'll just check on the things, rotation. Let's check on some things. We also want it to be like around when we like a direct transition from jump to running jump. And it still does it. Whoa, whoa. Oh, goodbye. Shouldn't do that. Rearrange. Hmm. Still jumps forward. It did do that before. We put this in. So it could do standing jump, but when we have speed, it jumps forward. Ha, ha. Jumping. Hmm. Okay, that didn't happen before. But let's just let's just preserve the transform for now. Form the x that position dot x is equal to 0. That's an error. Does it have to do with the jump? Yeah, I'll figure it out later. But for now, let's have it jump forward na lang. So we can proceed with other stuff. Okay? I'll figure it out later. It's still jumping. But we'll do a little more things. When the player hits an obstacle, we want it to like reset the screen, right? So for that, we want to do something here. If it collides with an obstacle, other dot game object dot compare tag obstacle, we want to reset the scene. Reset scene, right? or we have to reload the scene. For that, we'll just create another function so we could call it with a sort of a delay. So void reset scene. And then, so for this, we want the help of our scene manager. Typically, we don't do it here sa player script. Now, we usually create another game object, sort of like an empty game object, and then just so that it's in a scene and we attach a script to it. So it will manage our scenes or our level transitions, etc. But for now, just to make it simple, we'll attach it to our player. So we'll do scene manager dot load scene, meaning it will load the scene. No, well, yeah, that's what it does. And then we want to load the current scene. So we'll call scene manager dot get active scene, which is the current scene that we're in, and then we will get the build index of that scene. Because our load scene operates with the build index now. I think since our active scene is 0, we could also input 0 here. But just to be sure, we'll use get active scene dot build index, and then we'll call it here on an invoke function, invoke reset scene. And then on a delay of, I don't know, maybe 3 seconds after the collision, we'll invoke this. Okay. We'll also do some things if you've seen in the previous example, when he hits an obstacle, he like tumbles forward, etc. I'd like to call that like sort of a death tumble here. And I'll just create another function for it. Void death tumble. So we could just apply some forces to it so that we can sort of ragdoll our player. In this case, we just vector 3 death force, for example. Death force. So this is the force we'll apply to the player when it dies. No, I'll just say vector 3 dot up. So I want like an upward force, and I also want a force that goes to the right. So vector 3 dot right. There, vector 3 right. And I'll just multiply this with the jump force. Okay. And then I also sort of want a rotation. This case, let's call it death spin. In this case, I want it forward. And this is times jump forward. I will put this in angular velocity, and since angular velocity is much more subtle, we want to pump this up by maybe, I don't know, 100 force. And then we'll just apply it to the player. We'll just say player RB dot add force. Sorry, add force. Okay, and then we say death force, and then force mode is there. A similar thing, and we'll add some angular velocity as well. Death spin. So, and then we should stop it from running, which we should player animator dot set float speed f to 0. Okay, so it stops running. We should also want that our player should not be able to jump when it's dead, right? So let's create another boolean, private boolean is alive. So at the very start of the game, it is alive, so we'll put it is alive here. If it's on the ground and is alive, jump, right? We will set is alive to off here when it bumps into the obstacle. So it's alive, false. There. Uh, what am I missing? Okay. Hmm? Ang? Pwede man, but I'll leave it as is for now. We can explore that if you want. That's just a matter of setting booleans animate. Okay, so let's test out death and what happens when the character dies. Okay, so it's running. Bumps into an obstacle, bang. And then the scene resets. The problem here is that whenever we reset the scene, the physics kind of gets wonkier, it gets heavier. That is because whenever we load the scene, this line of code is getting called. Physics that gravity is gravity multiplier. So what we can do is we could sort of set a flag. How I did it last time was with a vector 3, pero dapat static siya. So private static vector 3. So a little refresher on scope of a static variable. Scope of a static variable, the static variable does not disappear or does not go out of scope as long as the execution is there. So at the start of execution, the static variable is there. If we declare another static variable, in this case, we're reloading the player controller, it should still be the same static variable. It shouldn't change. So if we have a vector 3, say initial velocity here, initial gravity here, let's set it to vector 3.0. So we're saying that our initial gravity is equal to 0. And then we'll have if initial gravity is equal to 0, there. If it is equal to 0, meaning this is the first execution of this code, then we will edit our physics.gravity times gravity multiplier. And after that, we will assign that value to our initial gravity, meaning it is no longer 0. So on the next iteration or the next time that the scene loads, this should still contain the value of that physics gravity. Okay, let's test it out. I'll figure out why it jumps later on, or like why it jumps forward. So if I jump forward, that's just the same distance. If I die, okay, it gets ragdoll everywhere. So if I jump, it's the same jump animation. Bang, gets ragdolled everywhere. Okay. Sige. Yeah. Okay. For now, that's it. Yeah. I'll figure out why it jumps forward later, but I'll just send like sort of a clarification about that. But for now, that's it. Any questions? Next meeting, we will be adding some sound effects as well as some visual effects and some more things to do with prefabs and procedural generation. Okay. Next meeting will be on March 21. March 18 is declared as a holiday. Okay. Okay. That's it for now. Dismissed.